All right, welcome to Powers of 10. First problem, 32 times 10. All right, 32 times 10, 320. All right, next step, 32 times 100 equals, that's right, 3,200. So we see that the digits are moving to the left, and we can also see if we're comparing zeros here, at least when we're dealing with a whole number. We'll see maybe decimals cut down the row. When we're dealing with a whole number, we multiply by powers of 10, we get the same amount of zeros in the number. So there's 1 0 here, 1 0 here, 2 zeros in 100, 2 zeros over here. All right, let's see what's next. Oops. No, that was incorrect. All right, so I'm going to introduce a term to you. The term is exponent. Okay, so exponent, what that is that's, where's my little laser pointer? Here. So this number right here, see, so this is 3 squared. So this 2 is the exponent. What that's telling us is how many, it raises to the power of something. And so for 3 squares, this is the 3 times 3. That's what it stands for. So 3 squared equals 9. 4 cubed, or 4 to the third power, means that it's being multiplied, the number 4, 3 times. So anytime you see this little number above anything, that is called an exponent, and it's telling you how many power it's been raised to, or how many times it's being multiplied. So let's think about the number 10. Okay, so 10 to the first power equals, what do you think? Yep, 10. 10 to the second power equals what? 10 times 10. It also equals, yep, you guessed it, 100. 10 cubed equals what? 10 times 10 times 10, which equals 1,000. So we can keep going on. 10 to the fourth, 10 to the fifth, 10 to the sixth, 10 to the seventh. All right. So now we're going to work on some problems using exponents and using the number 10. And let's see what we see. All right, so let's look at this problem. 32 times 10 squared. What do you think that is? All right, so 32 times 10 squared is the same as 32 times 10 times 10, or 32 times 100, which we'd already figured out, 3,200. So again, that 10 squared is 100. 10 squared, 2 zeros. 2 zeros are an answer, okay? With whole numbers. Let's see again what happens. All right, so what about the problem 32 times 1,000? I want you to try and solve it. I also want to think about how you might be able to rewrite it using exponents. All right, so 32 times 1,000 is 32,000, right? 3 zeros here. We have a whole number, 3 zeros at the end. These digits 3 and 2 have moved three spots to the left. How could we have rewritten this with exponents? Well, 1,000 is what? Up here, 10 cubed, right? So we could have said 32 times 10 cubed instead of 32 times 1,000. It's a little bit more efficient. That's why people use it, okay? It's a little bit more efficient. Let's see what's next. All right, so what about the problem 64,000 divided by 10? Try and solve it. All right, so when we're multiplying by 10, we know what happens, right? Our numbers shift to the left. We increase by a factor of 10. We increase at that 0, at least with whole numbers. So when we're looking at this and we look at 64,000 divided by 10, what's going to happen? Well, it's the opposite, right? Because division is the opposite of multiplication. And so when we're dividing by 10 in powers of 10, our whole numbers are going to decrease, or the number of zeros are going to decrease, or you can think of the digits going to the right. So this is 6,400. So we had 3 zeros, we divided by 10, now we have 2 zeros. We could, if we wanted to use exponents, rewrite this, saying 64,000 divided by 10 to the first, okay? Normally people don't do that. Normally don't have that first up there, but you can use that. You can. All right, so we're going to look at, here, let me zoom in a little bit. 64,000 divided by 10 squared. All right, so we're dividing by, this is 100, right? So this is the same as 64,000 divided by 100, which gives us our digits are going 2 spots to the right. So my 10,000 is going to stay in the hundreds. So this is 640. It's taken away, or it's, yeah, I don't like the whole zero thing. You know that. All right, let's look up what's next. What about 64,000 divided by 10 cubed? All right, so this is 64,000 divided by 10 times 10 times 10, which is the same as 64,000 divided by 1,000, which gives us the 64. Oops, 64. All right, so 4.5 divide 4 and 5/10 times 10. Let's see what happens with the decimal. All right, so 10 to the first is just 10. So what happens? We're not really going to see zeros here. This is why I don't like when we start talking about zeros, because these digits are shifting one spot to the left. So 4 and 5/10 equals 45. Equals 45. All right, let's look at the next one. 4 and 5/10 times 10 squared. All right, so 4 and 5/10 times 10 squared is the same as 4.5 times 10 times 10, because there's two tens in there, which is the same as 4.5 times 100. And again, our numbers shifted one spot to the left. Now they're going to shift two spots to the left to give me 450. All right, moving forward here. 4 and 5/10 times 10 cubed. All right, so that is 4 and 5/10 times 10 times 10 times 10, which is the same as 4 and 5/10 times 1,000, which is 4,500. All right, next up, 2 and 7/10 divided by 10 to the first. Divided, remember what happens when we divide? All right, so remember when we divide by powers of 10, our numbers go to the right. Our digits go to the right. So 2 and 7/10 divided by 10 is going to give us 0 and 27/100 because all my two digits shifted to the right. Now let's look at 2 and 7/10 divided by 10 squared. All right, so that is the same as looking at 2 and 7/10 divided by 10 times 10, which is equal to 2 and 7/10 divided by 100. And we divide by powers of 10. Our digits go to the right. So 2 and 7/10 are going to go two spots to the right. So I go from ones to tens to hundreds. So that's going to be 0 and 27 thousandths. It's time to fill out the form. What was this strategy? How did it go? What are your questions? And one more problem to solve. Bye.